Okay, Mr. Kelly, this is quiz 19, David Engell, and this is going to be a quiz on the tension and acceleration and all that good stuff. Actually, not really acceleration, just the tensions and such. So, number one, we have Tarzan swinging through the jungle with a mass of M and gets himself tangled between two vines, and here is going to be the free body diagram of that force. So what we're really concerned about is not about mass and whatever, because this system is static, so these two cancel each other out. But what we're really concerned about is the tension to the right and to the left. So if we construct this simple triangle here, we can find that the sine of the theta here is going to be equivalent to the mg over the tension in the right. So therefore, if we swing that over and swing that under, the tension in the right is going to equal mg over sine theta. And then, if we look at the diagram, we can see that the tension in the left is completely horizontal, which corresponds to this horizontal component of this triangle. So by finding this correspondent triangle equivalent thing over here, I don't know how to word that, we can find this corresponding tension over here. So, instead of using sine, we're going to use tan, as we have the opposite and we're looking for the adjacent. So the tension in the left is going to be equal to mg over tan theta. And those are your two values for number one. Number two asks, the water skier has a mass of m pulled along the water by a cord with a tension T at an angle of theta above the horizontal. So basically a similar question, and if we draw out the free body diagram here, we can see that the force of the water is going to be the mass times the gravity, or the normal force, minus the force of the tension in this rope here, and that is going to be T sine theta, that tension there, because this is theta, and then through the sine function you find the tension, blah blah blah, you know how it works. So that's going to be your equation for the force of the water. So the acceleration of the skier is going to be mg minus T sine theta. So 3 asks, if the water does provide a resistance horizontal force equal to negative kV, what is the general equation for the water skier's acceleration? That is just going to be derived, or not derived, but figured out from this, the original F equals ma, switch it around for A equals F over m. So if this is your force here, then you also have the subtraction of the horizontal force, which is the kV, so that's going to be subtracted from that quantity, and that's of course over the m. So you have T cos theta minus kV over m for the acceleration of the water skier. And that is quiz number 19.